Um, Good night, people, or good morning, or afternoon. We know that a lot of people that will watch this video will be through a video record. So thank you so much for being here and trying to learn more about synthetic biology, open source communities, and frugal biofoundries in general. My name is Isaac, and I'm part of the Friendscience team. And we're organizing a series of talks where we'll be like resource for the future that people could use for learning and understand interesting ideas in this topic. So to start today, we start with Chaz Childers. He's manager from application engineering team in Opentrons, and his talks entitled Democratizing Science with Open Source Hardware. So welcome, Chaz. Thank you for being here today.
Yes, thank you, Isaac, for that intro. And as you said, my name is Chaz. I work at Opentrons as the manager of the applications engineering team, where it's kind of our job to help scientists translate whatever they're doing to the OT2. And for those that aren't familiar with the OT2 or Opentrons, I'm sure by the end of this talk I'm about to give, you'll be a bit more familiar. So with that being said, I did prepare a few slides to kind of just help me gather my thoughts, and hopefully, this isn't, all old to everyone. So with that being said, why don't I just hop right in? So, right, so hopefully you can see my screen. Democratizing Science with Open Source Hardware. My name is Chaz. I have the Opentrons logo down below. As I said, I am affiliated with Opentrons. So a lot of what I'm going to say kind of comes through the lens of working at Opentrons. But I think there's plenty of other great organizations out there. Why don't I just go in? So a little bit about me. There's a photo of me, my title, and then an outline of what I'm going to be talking about today. We have the intro, democratization of the science, some open source hardware, putting it all together, and then I'll just close it out. I will be around for the entire talk. If there are any questions, happy to provide some answers there. So just a little bit about me. So, in 2008, I actually got accepted to go study bioengineering at Cornell University. Was really excited, thought I might go into medicine and help people that way. But at that same time, there was a lot of political change here in the United States. And so as soon as I arrived on campus, I actually asked my advisor if I could change my major because I thought that, while science is good, maybe politics is better. And I thought that, to enact positive change in the world, policy is the way to go. So without ever taking a science class at Cornell, I just dropped all my classes and ended up studying sociology, kind of with this goal of going into law school and going into politics and helping to devise policies for both the US and the globe. However, while I was studying sociology, I just learned about all of these problems, both local problems and global problems. At the same time, I became a little bit disillusioned with this idea that policy could actually solve these problems, right? If you ever watch the news here in the US and also abroad, I've seen it, you'll see that there's just like this kind of political gridlock and not much happens a lot of the time. So after, leaving Cornell, I was a bit confused as to how I might, provide some positive feedback in the world, positive change. So I was in Florida and I decided to go back to school, actually, where I studied biomedical engineering at FIU, Florida International University. And actually one of the first courses I took, while beginning this program was a physics course. That was a modeling-based physics course with this really incredible professor, Jeff Potvin, who really kind of transform my idea of what it means to be a scientist and what it means to be engaged in science. So, with that experience, I got really interested in how can we make science more accessible. Dr. Potvin, the physics professor, who was my first professor there, was part of what's called the STEM Transformation Institute. And, I had done some other sort of research while in this program, just, your typical lab research. But I got, really interested in how we might make science more accessible. So I asked if I could do some research with him or someone else in the STEM Transformation Institute. And I got introduced to Dr. Melissa McCartney, who came from the AAAS. And she had created this tool called Science in the Classroom. And there's a website, scienceintheclassroom.org, with the whole goal of making primary literature, so there's journal articles that we all, have seen, more accessible, because her central thesis is that, primary literature is science. It's, the standard currency in the, modern scientific world, but it's inaccessible to a large group of the population. So how can we make that more accessible? So she really wanted to make primary literature more accessible to the, students, in this case, like high school students. So, was really moved by the research, contributed to a paper that I'm, really proud of while in her lab, and then, graduated. So then, wondering how I might, provide this kind of positive change in the scientific community and make science more accessible, I happened to stumble upon this company called Opentrons that was making an affordable liquid handling robot with the goal of democratizing science and making, lab automation more accessible. I was really moved by this mission. And so I actually just reached out to Will Canine, who is the co-founder, and just basically begged for a job. I didn't know where I would fit in, but I was just like really moved by this mission. So asked if I could work for them. And this was in early 2019. Gave him my resume, gave him my background, and we connected. And here I am 2.5 years later. So now that a little bit more about me, I want to talk a little bit about the democratization of science. And so here, I pulled this from an article, and I'll actually allude to this article a little bit later too, that again, the co-founder of Opentrons penned. And here's, I think, a great quote from that article. So, he's struggling with this idea of, there are all these huge problems in the world. Climate change, how are we going to feed people? How do we deal with disease? And, this is really a political problem, sort of, and just like a societal problem. So how do we fix these? But, to Will, he thinks that the solution is through science, through biotech. And so that's great. All right, let's have the scientists create these solutions. The problem there being that we aren't creating these solutions fast enough. So it's, how do we accelerate that? Well, I think the answer there is that we just widen the net in regards to who can find these solutions. So making science more accessible, we're going to widen that net and allow others to contribute and, devise these solutions to some of the biggest problems that we as a society are currently facing. So here I've listed, and this is by no means exhaustive, some areas of improvement in the world of science. So, why isn't science accessible? So the first there is language. And, I kind of alluded to that previously when I was talking about my work with Science in the Classroom. I think that sometimes language makes science very difficult and can be very off-putting to some. I think that by creating or by using simpler language, it makes science more accessible. But there are trade-offs there, right? Because part of science is just being so exact. So, the choice of words is really important. But I do think that there can be improvements, let's say, to how primary literature and other scientific pieces of journalism are constructed. Another issue maybe, or an area that could be improved, is just publishing. There are some open source journals, which are great, but there's kind of this entire complex of, science that's hidden behind this wall, and you can only access it if you're willing to pay, or you have some sort of affiliation with another body. That's just one way that science is being non-democratized, right? You're only allowed to see the science if you're in the group or if you have the resources. So I think that improvements to the publishing industry could really open up, and accelerate scientific developments. Another area, tools, and I'll talk a little bit more about that, but the tools that scientists use can be very complex, and in some cases they don't really need to be that complex. Cost, I think that's pretty straightforward. Some lab equipment is very expensive. Again, I don't necessarily think it needs to be as expensive as it is, but just because there's no competitors, that's just what the cost is, and it's set by the companies producing it, and they hold all of the intellectual property behind that. So yeah. Additionally, there are some processes, and processes can mean a lot of different things. Whether it's an institutional review board, whether it's a lab protocol, some of these things just really slow down and hinder people from participating in the scientific world. And then finally, I have here misconceptions or conceptions. And again, just pointing back to my time at Florida International University and, in this transformative physics class, what does it mean to be a scientist? I think, at least for me growing up, I always had this vision of this, old gray-haired person, typically male with a British accent. And, that is the scientist. They are the authority. They know everything. I need to listen to them because they are in this position of power. But I think, recently, there's really been a challenge to what it means to be a scientist. And I am all for it. I love seeing, people from all sorts of backgrounds, all sorts of shapes, sizes, colors, standing up and saying, hey, I'm a scientist. I've done this work, you should listen to me. And I think that as we see more of those people, we'll begin to see just more and more people who might feel like they can't be scientists actually see someone that looks like them and actually, feel inspired to follow that path. Uh-oh. Oh man, I lost a slide. I'm really sorry. I was just going to talk about some current problems, but I think that we are aware of lots of problems. For example, CO2 emissions, COVID-19, affordable housing. These are all problems that could be potentially solved much quicker if, science is more democratized and people have more access to it. So without that slide, just going to this one, again, looking at that, referencing that article that I quoted earlier from Will. Will devised this idea and published in the article of a SynBio stack to accelerate, scientific research in the biospace. So in this stack, what you have are biological reagents, and he gives a few examples of different organizations and companies associated with that can then be used with these process execution tools. And that's where Opentrons kind of fits in as a tool, but there are other tools as well. And on top of that, you have basically the technology that puts those two together. And on top, you have the application. So what do you get when you put all of those, the BioCAD, the process execution, and biological reagents together? And if you haven't seen it already, I would highly suggest checking out that article on SynBio Beta. So I think that this is a great kind of system to think about when thinking about how we might accelerate scientific research. However, within this even, you still see a lot of kind of walls that are preventing people from accessing and doing science. So if we could open up some of those other arenas, make more tools that are open source, more reagents, and maybe more BioCAD and CAM tools that are open source, cheaper, easier to use. Who knows what we'll see in the next 10 years. Oh, there's a few of the challenges. Didn't want to list too many because there's, definitely a lot of problems in the world that I think could be solved by science, and specifically, biology, biochemistry. So now, thinking about open source hardware, there are a couple organizations that are producing and actually selling open source hardware. So obviously Opentrons, I have an image of, our robot and a deck layout there that's kind of transforming. And so for those unfamiliar, the Opentrons is an automated liquid handler. It's an automated pipetting system. So you're able to transfer, microliters of liquids around. And this is basically a core tenet of, synthetic biology, moving liquids around, doing things like nucleic acid extraction. If you wanted to set up a PCR reaction, NGS library prep, those all kind of require some sort of liquid handling, upstream before you can do that downstream application. So the Opentrons robot is really great, I think. And, I'm still at Opentrons because of it, because it just really is a flexible tool that can be used in so many different ways. And, all of our code is on GitHub. It's open source. Our hardware schematics are also open source on GitHub. And so, we have this kind of guided way as to how maybe a user might use the OT2, but there are plenty of people out there who've transformed the robot and made it into something completely different than how we kind of envisioned it. And that is incredible to me. Rather than using the pipettes that we've developed, they will, stick a syringe and use this custom syringe for some custom application. And so I think that's great. And having, people able to, kind of play around with these tools, I think really will help accelerate, again, that research and development. Another tool, another piece of open source hardware comes from OpenPCR, and that is a, easy to use, affordable thermocycler for PCR reactions. And, I mentioned before an problem that we're currently facing is COVID-19. I think we're all impacted in some way by COVID-19. And I know that at the beginning of this pandemic, a lot of people struggled, a lot of governments struggled to develop testing methods. And, PCR continues to be kind of the gold standard for COVID-19 testing. And, with these two tools, you kind of have almost all of the hardware that you need to do COVID-19 testing. You would need reagents and you would need samples and, some way to kind of read those results at the end. But, this is a very low cost, affordable. If you have the tools, you can make these kind of from scratch and just set up a COVID-19 testing lab. And that to me is so powerful and so incredible. But in addition to just organizations, and these are just two examples, there are a ton of great projects. And I'm sorry if I'm just reintroducing projects that everyone here is already familiar with. But continuing on that COVID-19 testing lab example, we have here on the left an open source plate reader. And for those that don't know, when you do sort of any kind of fluorescence-based assays, you need to be able to, read the results of that fluorescence. So having a plate reader is kind of critical. It's pretty critical in that regard. So here is an example of an open source plate reader. They have all of the schematics provided online, as well as all the software needed. So, I'm sure there have been many iterations built on this. This was, developed a few years ago. And then on the right, we have this really interesting example of, a pretty ingenious centrifuge idea that I found on Thingiverse, the 3D printing MakerBot website, in which, and this is from over a decade ago, where you could kind of create this low-cost centrifuge and use a Dremel or a drill to actually spin and insert your standard microcentrifuge tubes there. I'm not sure how well it works, but these are projects that people have put together, and these projects kind of float all around. So it can be hard to figure out and find all of them, but they are out there, and I think that these are can really lead to the next generation of just open source hardware companies. So, the goal of this talk and the title of the talk is Democratizing Science with Open Source Hardware. So, and again, I apologize, I'm coming at this through the lens of someone at Opentrons, but how do we actually make science more accessible with this open source hardware? And so on my team, as an applications engineer at Opentrons, what we do is we are in charge of what we call the protocol library. And the protocol library is, they're basically two iterations, but they exist kind of as mirrors of each other, and they are. One is a GitHub repository, github.com/opentrons/protocols. And this is an open public repo on GitHub that contains over 400 protocols that will run on the OT2. So someone who's never been in a biolab before can find a protocol for an NGS cleanup, or for an RNA extraction, or a myriad of different processes that maybe they have no training, they've never done in their life, but the software that will make the OT2 perform that assay, that kit is all there. It's all free. It can be remixed, and I think it's pretty easy to use and to find. And then we have an even easier and more kind of straightforward version of this called the protocol library, which is at protocols.opentrons.com, and is actually just fed directly from our GitHub repository. And so this is a more user-friendly, basically, face of the GitHub repository that isn't as maybe tricky to navigate as a GitHub repository, but still allows users to find protocols and actually modify those protocols pretty easily with drop-down parameters. So, if I wanted to do an RNA extraction, let's say, and I have 10 samples, I don't need to know how to code. I can just select 10, download my protocol, run it on the OT2, and then, put in my 10 samples, and at the end, I have 10 samples of, RNA. So in closing, I just wanted to, return back to this idea of democratizing science with open source hardware, and actually go back to that SynBio stack. And I would say that the protocol library kind of fits in those two. The protocol library with the OT2 fits, in the BioCAD and process execution. But I'm really interested in what Friendzymes is doing, and I'm really excited because, to me, it actually covers the entire SynBio stack there, with the reagents, the execution, the software, and then the actual application. So I think, this is really the start of something quite epic. And I'm actually not aware of any other sort of project kind of this nature. So really excited to see how this all turns out, and, happy to contribute in any way I can. So I think I'm at about time. And so, yeah, I see a few comments. Centrifuge worked. Great, Devin, thank you for for that. And, thank you again for allowing me to chat. I'm here if there are any questions.
Thank you for being available and have this talk. I think one question that I have is that in Brazil, I think in the 90s or in the, I think 10 or 20 years ago, we have a lot of companies buying um, automatic pipetting systems. And most of this hardware are relics that actually works a lot, but they don't. But a lot of I know that a lot of labs in Brazil, they have these machines, but they couldn't use because the firmware of the software, they don't have more of this license. And a bunch of friends of mine are thinking about trying to mix Opentrons. I will not say the name of the companies, but we will try to mix things and try to hack some of those machines. And I was reading some documents and everything, kind of trying to. And you say something, and I would like to ask you about one thing that is, if someone tries to create an Opentron from zero, like we have this Prusa, I forget the name, Prusa MK2 that prints, it's a, I forget the name of the machine. It's a 3D printer, actually. I remember. It's a 3D printer. And one of the things that people do is they buy one and they use the first one to create the second one, right? So, and one of my questions that if you see someone try to create from zero, if Opentrons have all the schematics downloading and everything, if they try to build this, because this could be like a proof that people could use old legacy hardware for actually hacking and creating one from there, right?
Yeah, so there's kind of a lot to unpack, and you touched on a lot of really interesting ideas. It's a question. So, and I just want to make sure that I'm answering, everything correctly. So the question here is, can we just create an OT2 robot from scratch? If I have some metal around and some electronics, can I create an OT2 from scratch? In theory, I think you probably could, although it'd probably be very difficult at this point. I think it's, and it's a hard rope to walk on, because you want to create a product that is accessible, but you also want it to be usable. And so I think that the first iteration of the Opentrons liquid handling robot, the OT1, was a little bit easier to reproduce. And you could make it with kind of off-the-shelf parts. However, there were a lot of issues because of that. And so the second iteration of the robot, the OT2, resolves some of those issues, but by doing so, it becomes, you need some manufacturing capabilities, I would say, to really reproduce it from scratch. If you just had the schematics and had all the tools and, kind of instructions, if you will. So yeah.
But I think I kind of just at the point of reliability, because we are making hardware for science, we actually have to increase the quality, the final quality, to be able to make those. But it's good to hear that we have a version, at least, of the O2 that actually is more, could be more interchange. Thank you.
Yeah, and you touched on a few things that I kind of forgot to touch on, which is you began with the story about these tools that basically become, giant paperweights because you can't use them because the software doesn't exist anymore. And, that's so unfortunate. And, I probably should have prefaced this, it's really hard to say, oh yeah, this is a great piece of open source hardware without saying there's also this software component that's also open source. And, it really is infuriating when companies do things like that, I think. And for whatever reason, they just make this, labor of love that they've created just unusable by anyone. Even if it was working pretty well before, like, I'm sure scientists were using these tools before in Brazil and could probably still find uses for them if the software was still supported. So yeah, having an open source software that powers your open source hardware, I think is really important as well.
Hi, Chaz. I have a question. So what's the current focus of your team? What kind of applications are you working on? What's like the cutting edge of the software happening right now? Oh, you're muted.
Sorry, I shared the protocol library, our GitHub repo full of protocols, and one of the things, I mean, it's not really an application like a PCR or NGS library prep or anything like that. It's actually just this idea of making that whole tool more accessible to users, because a lot of people aren't super familiar with GitHub, and GitHub is currently the only way to contribute to our open source pool of protocols, our library of protocols. So I can be a scientist all the way in Brooklyn, let's say, which isn't that far from me, I'm in New York, who has created this great protocol. I want to share it with the world, but I don't have a great way of doing that. So how do I share this? Well, hey, there's this huge group of people that use the same robot I do, and they go and check out this, this page, the protocol library. Maybe they would find use. However, I don't know how to contribute. I can't contribute because I don't have that GitHub background, or there's a lot of friction between developing a protocol and sharing it. And so to me, I think the big goal for the rest of this year and early next year is just making that platform more accessible, and also allowing people to comment and talk about troubleshooting, and just continually iterate on these protocols so that scientists everywhere have access and can perform and reproduce science all around the world with our platform.
Boy, it sure would be nice if you had like a team of noobs who just got robots who are going to try to work on them, and that you use as guinea pigs for this process.
That would be great. That would be great. And I think there might be something in the works.
Also, it's good to see that people could actually contribute to the protocol library. That's not a static project, right? This is not something that you're trying to show to people that have a big source project, but it's actually a functional part of the company that actually wants to have people contributing to with protocols that could be better than the actual ones that you're using, because they are actually the expert in the topic, right? That's good to hear.
Yeah, exactly. And I didn't really touch on this. Again, I'm coming at it through the lens of Opentrons. In addition to our Python API, we actually have another tool called the Protocol Designer, which is a no-code way to basically set up the protocol that you want to run on your robot. And I was actually just reading this paper by João Paulo out of Harvard Medical School, who did this great work on the OT2 and had actually shared his protocols, but they were all written using this other tool, Protocol Designer. And currently our protocol library does not support sharing protocols designed in Protocol Designer. So being able to share protocols developed both in using the Python API and our no-code solution, the Protocol Designer, I think will be a big move forward.
another thing that I would like to comment is that taking a look in the Opentrons API is that you could actually customize to use different equipments, and this could be also import in the repository, so people can reuse these equipments that are not the standard ones in the Opentron, but they are the most used ones, right? So people could actually increase the equipments that Opentrons could support in the XYZ from the Opentron by actually make a process of iterating the exactly places where the machine will receive the liquids, right? And I think that's another thing that I will actually, I'm very excited also to contribute.
Yeah, definitely. And, again, I feel bad for talking about Opentrons so much when the goal was just talk about open source hardware. But yeah, it's a very flexible platform. But what I think would be really great, and there's really no one stopping anyone from doing this. It would be really incredible if some other group, someone out there, use the OT2 and build other hardware that could communicate and you could talk, and the two tools could work together. And there are a few examples. I don't know if they're necessarily open source companies, but for example, Q Instruments developed a heater shaker that fits on the OT2 deck. They developed the drivers, so you can just download them, and you can use this heater shaker on the OT2. And this was something developed with no collaboration between the two companies, to my knowledge. But it's just one example of like, hey, we see the OT2, it's a potentially great platform for something else. Like, why don't we create X and integrate it and allow people to integrate the two?
Could you paste or type the name of that product in the chat so we can
chase it out later? Yeah, so let me look it up really quick. Huge. So I will prove. So yeah, this is their heater shaker. And like I said, they have a Opentrons integration. They've developed the drivers, which you can do because the OT2 is open source.
I think my last question is about, we are seeing some people commenting about autonomous biofoundries. The idea that to improve synthetic biology, to actually advance in the field of biotechnology, we have to try to actually make biofoundries more autonomous, and actually having people behind the wheels, I'll make this, I'll use this word, to see how much we could actually automatize and how much we could increase the high throughput of experiments and everything. And one of my questions is that what Opentrons or you actually think about this topic, and if you have something interesting to say about it.
Yeah, I mean, I think this is an incredible idea, and I think kind of the core of what Friendzones is doing, correct? And super excited. I included that in my last slide just because of how excited I am about this idea of creating a somewhat low cost, affordable, accessible kind of entire stack for doing biotechnology, synthetic biology. Yeah, how can we make it better? I want to help. I want to send some code. Let me know. I think this is a really great idea. One, because, while some of this knowledge is accessible, it's out there, it can be really hard to navigate and understand exactly what sort of reagents, what sort of tools are needed. And so just having an entire package that works super well together, I think is incredible. And it's kind of, I mean, the analogies, there's a ton of analogies, but one that just pops into my mind is like, you know, you can have all these different pieces of hardware and electronics, and you can package them and sell them together to create a computer, or you can just kind of buy a computer that's already put together, and you don't need to understand everything and how it all fits together, but you can still use that tool, right? Like I can use this computer and do things, although I don't necessarily understand how it all fits together and how it all works, but I can still use this tool to create. And so, you know, having these biofoundries that are comprised of these other tools will allow, I think, others to kind of create on top of it. So.
Okay, any more questions about the topic, people? So, okay, thank you so much, Chaz, for giving us some of the time and some of the ideas that will be recorded and shared with, I think we have right now people from all the 5 continents that will be in the hackathon. So we're really happy to share the word of Opentrons to all those people. Thank you so much.
Yeah, and thank you for having me. It was a pleasure.
Okay, so
yeah, I just hopped on, Chaz, but I'm with BioBlaze. So yeah, on behalf of BioBlaze, thank you for your sponsorship.
Yeah, thanks for sponsor for sponsor us in general.
Yeah, I mean, it's not me. It's this group that really deserves all the praise. So.